Well, hello, everyone. Thank you for joining this Zoom chat on high temperature foaming agents. We do have a couple products that we use for high temp applications. So when you're talking about PC polycarb, PC ABS, PC BBT, nylon, glass filled or otherwise, the 71896, our high temp foam, that is the product we would obviously recommend. This product kicks off at 400F. It is designed for polycarb, so it's a non-hygroscopic material that works great in moisture-sensitive materials. The other product we have is a 75553. Now it kicks off at 380, and it is non-hygroscopic as well. That product we designed for extrusion blow mold because they have such a range of either in the 400s or in the 360s. So if you're the 400, we recommend the 75553. If you're going lower temperatures than that, we'd probably recommend our 6851. But nonetheless, these are the two products that basically they don't have to be in engineered grade materials either. I mean, if you've got a profile or a lot of shots in the barrel and you want to get that material to go off later down the barrel, these two will work in olefins as well. But they were designed for polycarb, and we've done a lot of polycarb and nylon with this material. The 71896 performs great. Letdown ratios 1 to 2%. And when it comes to aesthetics, the 71896, even though it performs great in polycarbonate and nylon, aesthetics, remember, foaming agent's all about heat. The hotter it is, the more active it gets. Really doesn't matter what foaming agent you add, the hotter it is, the more active it gets. And you really need to try to control that the best you can. But to do an aesthetic polycarb is a little bit challenging. It's not that it can't be done. It's a little more difficult than, say, a non-aesthetic application. So, and all chemical foaming agents, including our high temp foam and just any other foaming agents, they're all process aids. They reduce viscosity. They improve flow. So we always recommend that if it's reducing the viscosity, which it always does, then you need to address barrel temperatures, depending on how many shots are in the barrel, to adjust temps. And when it comes to nylon or polycarb, adjust the temperatures a little at a time. Don't go crazy with it. Focus on the rear zones for sure, but you can come off the rest of the temperatures. I just say go slow at it. Find that spot where it works the best for you. Let's see. So the price of nylon and polycarb is ridiculous. They're not the only ones, other olefins, and everybody's interested in trying to offset that cost or maybe extend the amount of resin that they purchase. So by taking some weight out, if capacity is an issue, then cycle sometimes becomes more important than weight. Although you're always going to drop a little weight. It just depends on how much foam you use, how much weight you want to pull out. And again, injection velocities are important. So when it comes to these materials, how I would process it is I would take the pack pressure completely off. I'd inject it all one speed till it hits transfer, whether I need more material or less material, but I always try to make the part go short and then try to increase my injection velocity to fill it a little faster. And that's how you can play with it. You can adjust your injection velocity. If it's full, then you can move that transfer up, make it go a little short, and see if you can get a little more speed, because that's what's going to pull the majority of weight out is the injection velocity. And high temp foams, I mean, the 75553, we have had some fantastic results in injection molding of olefins, as well as, we designed it for extrusion blow molding for OEMs. So it does perform quite well. And the key to extrusion blow is blow pressure and temperature. So always take advantage of the viscosity that the foam that gives you to allow you to pull temperatures out. Remember, if you can pull heat out of any polymer, it doesn't matter what polymer it is, it's going to improve that polymer. It's going to improve impact. It's just going to help the polymer. So we highly recommend you reduce your barrel temperatures. And that's about it for high temperature foam. I mean, it's a low pressure application. Inject quick, get off it, let the foam do the work. And it certainly will. It'll pack it out beautifully. So that being said, do y'all have any questions? So the 71896, it's good up to 600 degrees. I mean, you could probably go a little hotter, but for polycarb, not very often you see 600 degree temperatures. So we're well within the parameters of polycarb with the 71896. It'll handle up to 600, maybe even more. But we've never ran it in like Ultem that runs above 600. I've always wanted to, but I haven't. But yeah, it'll handle it up to 600 degrees. So you should be good. Now we do have foaming agents with different gas yields and different kickoff temperatures, but we don't combine a couple foaming agents to like for polycarb. 71896, that's the only product we use, and it performs great. But we do have different products that even that kick off at different temperatures, have different gas yields. Just depends on your application. A great question. ABS, you don't need the 71896 for ABS. You don't. The impact of these materials depends on how much weight you pull out of it. Just like any part, if you take a bunch of material out, it's going to affect the structural integrity of the part. So we want to, if you have impact requirements, we definitely want to address those as typically impacts are plus or minus, right? So you have this range of impact. You got, and typically when you're not using any foam at all and molding parts, you know, what I see is everybody likes to be at that higher end of impact, which is, you know, it's going to pass with flying colors. You do have that range. So you have the lower end, which passes, but it isn't as, it doesn't perform as well as the higher end, but it's still within spec. And that's what we would do, depending on where that is. But we would bring, we would take only enough material out of it to keep it within that spec. So yeah, we're not going to drop it below spec. We'll try to keep it all. If that's 3%, if that's 5%, that's where we'll hit. Good question. Agent is a flow enhancer. It is a process aid. It will allow glass-filled, calcium-filled, talc-filled materials that allow them to flow better and easier. Now, glass pushes hard. I mean, these high-temp polycarb, nylon, PCABS, PCBBT, they all push harder than normal olefin. We all know that. But the foam will improve that flow and will help you fill a tool with either long fibers or even short fiber glass. So we definitely recommend, we don't have a problem running in glass-filled materials. It does open the process window. It does allow it to flow easier. Yes, they are. They are non-appearance. If you want to go maximum weight, that means you have to fully foam it. And remember, you're only going to pull out as much weight as the machine's able to fill it. So just at your standard process, taking the pack pressure off it, you're going to drop weight. If you want to keep it aesthetic, that means you got to use way less foaming agent. And then that speed becomes real crucial at that point to keep the foam in the wall. But maximum weight is fully foamed. And then if you want to pull, I mean, you're going to get weight regardless, right? As soon as you take that pack pressure off, you're going to get weight. Now then, if you increase your velocity, the weight keeps coming down and down. And that's non-aesthetic. And it's the same process with aesthetic parts as well. Get it in as quick as you can, get off it. And then at that speed, you can only use so much foam. If at your max speed, you start seeing splay on the surface and trying to make it aesthetic, we have to look at barrel temperatures, and then we'll have to look at velocities, because at that velocity, you're pushing it to the surface. So that means you probably end up having to drop the percentage of foam just to make it aesthetic. But non-aesthetic, maximum weight, maximum cycle, that's what most of everything that I've done with polycarb, that's been non-aesthetic. Yes, we do. I believe the 75553 and the 71896, I believe they've got FDA certs. Of course, you know, if you need this information, we'd be happy to give it to you. Send it out to you. 896 should not change any colors of the polymer. It should be white, if anything. It'll be maybe a white splay on the surface, but as far as color-wise, it shouldn't affect the color of the part, other than just you might have splay on the surface. And if that's the case, and you don't want splay on the surface, you gotta either speed up the injection, or you'll have to drop the percentage of foam. But it shouldn't affect the color, other than the splay will make the color a little lighter if the splay is on the surface. If there's no splay on the surface, you shouldn't see any color problems. And when you're, and you ask about, you know, if the temperatures are higher, does it affect the weight? Well, if the temperatures are higher, which I still recommend you take advantage of the viscosity change. But if the higher the temperature, better the flow. I mean, that's what we run into whenever we go to places. And I look at the barrel temperatures, and the barrel temperature elevated to, I think, higher than they need to be. And I understand why that is. It's just, it opens their process window. If you run a little hotter temperatures, you get better flow. You don't have to worry about the process so much. But higher temperatures will improve flow. It'll drop viscosity, and with the foam in it, with the higher temperatures, it's really going to drop viscosity. So even with higher temperatures, you should probably see a little better weight reduction. Good question. We don't recommend, you know, cranking your temps up if you don't need to, especially polycarb, nylon, things like that. These are high impact polymers. And if you can run them a little cooler, that's the best thing for them. Thanks, great question. Outflow index is, you know, if it's low, it's a stiffer material. If the melt index is high, it's not as stiff, it flows better. Foam does, if you've got a low melt material, the foam will open that up. It will actually allow it to flow much better, even though it's, you know, it's a low melt material. It pushes a little harder. It acts different than, you know, a high melt, obviously. But even at low melts, the foam's going to really open up that process window. It's going to allow it to flow much better. You're still going to be able to take a little temperatures out of it as well, which we always encourage. But that's a great question. Thank you. Back in the day, years ago, 1/4 inch wall and up was pretty much all they did with foam. I mean, they targeted really thick parts to pull that mass out of the part. But nowadays, you know, we're foaming, you know, like a 28 thousandths wall, 30 thousandths wall, with anywhere from 7 to 12% reduction in weight, as well as cycle. So it used to be, you know, the thick parts, they're the ones to go after. But nowadays, with our microfine cell, we're able to do thinner walls and still get substantial savings. Now, obviously, thicker walls, you get more weight pulled out of a thicker wall than you do a thin wall. But we can do both now, and we can foam them aesthetically with high gloss surfaces. You wouldn't even know the foam's in it. And that's all machine capability. I mean, if your machine can do it, we can produce some really cool stuff. So that's a good question. Like this content, please subscribe to our YouTube page. We're going to be doing a lot of these in the future. So if you don't mind, go ahead and subscribe to us, and that way you're up to date on everything that we put out. Things there. If you're running a thick wall polypropylene part, again, your temperatures mean a lot. Typically, thick wall parts have longer cycles. And so this is how I would approach that. And it's a great question, but this is how I'd approach it. What's happening, a couple things. What's happening most likely is you're losing all the gas out the back. That's what I'm guessing here. I mean, I would probably like to talk to you a little more in depth about it, but it sounds like that sometimes you have good parts, sometimes you don't, which means you're probably losing gas up the rear hopper. You should be much cooler back there, and your residence time. If you're zipping it back and it's sitting there waiting for that mold to open, well, that gas is going up the hopper. You're losing it. So I would recommend that you don't need any pack pressure, just pack time. You have to freeze that gate off. If you don't freeze the gate off, it's going to try to pump material into that part, and your weights are going to go up. I mean, I've taken, and this, I learned the hard way, and this is years ago. I took 2 inches out of the shot, and the part never did go short because I wasn't freezing the gate off. So if you don't freeze the gate off, it's going to pump more material in. It's going to take that weight savings. It's going to go away. If you're losing it up the hopper, you're going to have to adjust residence time, and this is why I'm a firm believer in residence time. You need to only have enough time to freeze the gate off. Once the gate's froze, then you have to turn your RPM down and creep it back until it gets back within a few seconds of the mold opening. When you do that, you're going to find, and lowering the rear zones, and look, we need to talk about those barrel temperatures, and I could set up a nice profile for you, but you need to try to optimize that gas. And with that residence time, it keeps everything moving. Nothing sets there and bakes. It just keeps everything moving, and you get a little more consistent shot to shot. And when you bring those rear zones down to where most of the activity is up front of the barrel, then you've optimized the process. You're always going to lose a little gas, but you're going to lose way less than you were. So I'd like to talk to you about that if you don't mind. But great question. colors will affect impact characteristics. Doesn't matter what material it is. It just depends on how much material you pull out. So if you've got impact requirements that you gotta hold, then again, we're only going to add what to keep you within spec. We don't want to go below that because then you're going to have failures. You know, we definitely want to keep you within spec, and that can be done. And I'm assuming, and I did ask if there was nitrogen, and they said, I believe they answered yes on that. So I kind of wanted to go offline to discuss this with you because there's a lot of things going on that I think can help. But the biggest thing is nitrogen. And I've run into this too. We call it blisters when it comes out of the mold and you see it blister. We call it post blow when it comes out of the mold. It looks great, you know, and a week later or 10 days later, it's in a warehouse, hot truck or warehouse, and you start getting this post blow. And that's because you have way too much nitrogen involved. So you're trying to pull all that weight out with the nitrogen, which is not a bad thing, but you got to understand when you add all that nitrogen, now you run into structural integrity issues. I don't know if you've ever seen a structural foam part, forklift hit the corner of it, it breaks and you see this big void. Well, that big void is what's causing the blister. So you have to bring your nitrogen down. And this is how I would approach this. I would turn your nitrogen down till the part goes a little short. And then I would see if I have a little injection velocity to fill it. And then I would turn the nitrogen down even more. If I'm filling with velocity, I'm going to turn that nitrogen down a little bit more, get it in quicker. You're actually going to keep your weight and you're going to have a much, much stronger part, structural integrity, and you won't have post-blow issues. But with the nitrogen high, and if you're using chemical, please keep in mind that when you're using like, let's say 0.5 or even 1%, and you got your nitrogen at 12, 14, 15, 1600 PSI, it'll overpower that chemical. So you need to bring that down until you get a nice balance between the two, and then you get the best of both worlds. But great question. I would like to go over barrel temperatures with you. I'd like to go over the process with you when you get a chance. I'd be happy to talk to you offline about that. Great question.
Hey, Chris.
Don't have, you know, I know that, you know, if the rib is thicker than wall, you're always going to get sink. If you get the foam in quick enough and get enough in the wall, it'll blow that sink out and you wouldn't know it. Or if you fully foam it, it'll blow all the sink out. But I prefer the wall being a little thicker than the rib. Wherever that is, that's what I prefer. Everybody for attending this Zoom chat. Some great questions. I hope I answered them the best of my ability. If you know, I'll try to reach out to some of you guys. But what we offer lunch and learn. So either it's on-site or remote. I do a lot of remote tests all over the world. Very successful with that. Our lunch and learn is basically we buy you lunch and we go over our products and just kind of introduce ideas to you guys and what we bring to the table and what we can offer you guys. If you like this content, please subscribe to our YouTube page. We're doing really well on YouTube. We just ask if you like it, subscribe, and we'd appreciate it. We do offer on-site trials as well. I do go to facilities and work with your process engineers and whatever tool it is. When I go places, I don't know what the mold is. I don't know really what the machine's capable of doing. It's when I get there, we kind of work within the parameters that we have to give you the best results possible. So again, thank you so much for joining this Zoom chat. Subscribe to YouTube, and we look forward to seeing you on the next one. Have a great day.